For this video, we're going to continue solving trig equations, but this time, instead of looking at trig equations that can be solved using the unit circle, we're going to look at trig equations that require a calculator to solve them. All right, so for each of these examples, I'm going to tell you what the answer would be if we're looking for solutions that are between 0 and 2 pi, and then if we're looking for just the general solution if you wanted all possible answers. So first, since we don't have a unit circle to look at for 1/3, we have to draw the picture ourselves. So if I think about which quadrants would have ratios for sign that are positive, it would certainly be the first quadrant because everything is positive in the first quadrant, and then it would also be the second quadrant. So I'm going to go ahead and draw two triangles, one in the first quadrant and one in the second quadrant, and for both of those triangles, I'm going to show that the opposite side is 1 and the hypotenuse is 3. All right, so if you guys recall, your calculator likes to think in terms of functions. So if you guys remember when we would solve this, we're going to do sine inverse of each side. But my calculator is not just going to give me all of the answers. My calculator is only going to give me the answer that would work for the inverse function, not the inverse operation, which is what we're doing. It's the same idea as if you square root 4 in your calculator. It's not going to say plus or minus 2, it's just going to say positive 2. And you have to know, oh, I was the one who did the square root, I need to put the plus or minus. So here, we're going to be doing sine inverse of 1/3, and I just have to know that my calculator is only going to give me an answer in quadrant 1 or quadrant 4, because that's where sine inverse function answers come from. So my calculator will only give me this answer, it will not give me this one. So I have to figure out how to find that second answer. So first, I'm just going to make sure that I'm in radians because we're finding answers between 0 and 2 pi. And then I'll go ahead and type sine inverse of 1/3. And that's 0.340. 39 followed by an 8 would be 40. And I'm going to go ahead and store this as x because I'm going to need that decimal in a moment. Okay, so the amount of this angle was 0.340, and that means that the amount of this angle right here is also 0.340. So if we measured angles from the negative x-axis up, then we'd be good. We'd have both of those answers, but we don't. We measure this second angle, we would measure like this because we always measure angles from the positive x-axis. So that means that to get my second answer, I want to do all of pi, so this whole thing, all of pi minus 0.340, and then that would give me my answer. So I'm going to say pi minus 0.340 is what gives me my answer. And what I stored in my calculator as x is what I need to be subtracting from pi. So I'm going to do pi minus x. And that gets me my second answer. So theta is approximately 2.802. And so this is the trig equivalent of us saying like, oh, I square rooted something and I had a positive answer and a negative answer, plus minus 2. This is kind of like having those two different answers. So these are the specific solutions from 0 to 2 pi. If we're looking at all possible solutions, then we would say 0.340 plus 2 pi k, and we would say 2.802 plus 2 pi k. So I could take these decimals and be adding or subtracting 2 pi to get those coterminal angles. Okay, so let's go ahead and do another one. we're going to go ahead and do sine theta equals -1/5, just so we can have the negative version. So I know the positive version of sine would show up in quadrant 1 or 2. That means the negative version shows up in quadrants 3 and 4. So I have opposite over hypotenuse. And I know that when I draw these triangles, the side that would have to be negative would be this side because it goes down 1. The hypotenuse should never be labeled as a negative. So now I need to think about how my calculator is going to measure these angles. And if you guys recall, when we do sine inverse and the answer's in the 4th quadrant, we always label the angle as a negative version of whatever. So that means our calculator is going to give us a negative decimal, and it's going to have measured it this way. So if I think about how to undo the sine so I can get theta by itself, I would do sine inverse and sine inverse. And I'm going to get that theta equals sine inverse of -1/5. And so theta is -0.201. All right, so I'm going to go ahead and store that as x. All right, now this answer would be good if they said they wanted all solutions. So for all solutions, I could say that I have -0.201 plus 2 pi k. But if they're telling me they want this answer to be between 0 and 2 pi, then I can't keep this because that's negative. So I'm going to go ahead and take that answer and add 2 pi to it. And the purpose of doing that is to find a coterminal angle that is between 0 and 2 pi. So this would be 6.082. That's our first answer. And then we have to think through how we would get that second angle. So this angle right here is -0.201. So if I want to measure this angle the way that we do it normally, we would want to measure it this way. So we would want to have all of this part right here is pi plus 0.201. So what I'm going to write is if I had pi and I minus the -0.201, if I do pi subtract that angle, then I'm going to get my second answer. So all of pi minus -0.201, because minus minus makes a plus. And so I can see that that's going to give me that whole angle. So to get that angle in my calculator, I'm going to do pi minus what I stored as x. So 3.343. So that would make our general solution 3.343 plus 2 pi k. All right, now the reason I did not say 6.082 plus 2 pi k is because this answer actually came from this equation. So there's no reason for me to write this one plus 2 pi k because it's technically the same. So there's one answer, there's the second answer, and we have come up with our first shortcut. So our first shortcut says for sine, the second answer is pi minus x. And what I mean by x is the answer you stored in your calculator when you first did the problem. Okay, so this is our first shortcut. Star it, make it in bold, underline it, do something. We're going to memorize this shortcut. Okay, all right, next let's go ahead and do cos. So here we're going to say cos theta equals 2/3. And so again, I'm going to think all students taught constantly. So we're definitely going to be positive in the first quadrant, so I need to draw a triangle in the first quadrant. I also need to draw a triangle in the fourth quadrant because that is the other place that cos is positive. So theta, we're going to have adjacent over hypotenuse. Theta adjacent over hypotenuse. All right, so to solve for theta, I'm going to do cos inverse and do cos inverse. And so theta is cos inverse of 2/3. And I know that when I do cos inverse, the answers that I get in my calculator are the ones that are in the first quadrant or the second quadrant. And so when I type this into my calculator, it's going to be giving me this answer right here. So I'm going to do cos inverse of 2/3. That gives me 0.841. I'm going to go ahead and store that as x. And then if I was doing all solutions, I would say 0.841 plus 2 pi k. Okay, and so the way that I have to think about this is I know that if that is 0.841, then this angle right here is 0.841. That's the number of decimals that are right there. But that's not how we measure our angles. We measure like this. So to find cos of the angle, we're going to say the entire circle is 2 pi, and I want to minus off that little bit. So what I'm going to type into my circle, sorry, not my circle, my calculator. What I'm going to type in my calculator is 2 pi minus 0.841. So I'm going to type 2 pi minus what I stored as x. And I get 5.442. And so for all solutions, 5.442 plus 2 pi k. And so here are my two solutions that would show up between 0 and 2 pi. And then there's my equations if I want to find any more answers to terminal angles. Okay, so same thing, we're just going to do the negative version. So here, if we have cos theta equals negative 5/8. So this time, instead of quadrants 1 and 4, we're going to have quadrants 2 and 3. So adjacent over hypotenuse would be 5/8, 5/8. Again, the hypotenuse is always positive, and so this adjacent side would be left 5, and that makes that the negative. All right, and so here, if we remember how cos inverse functions, we have a second quadrant picture, and so our answer is going to be in the second quadrant. And these were not weird. If you guys remember when we did this, when we looked for cos inverse problems that were in the second quadrant, you just looked at the answer and it was normal. And so that means that it's going to give us this angle right here. So it's going to give us the answer the way that we would want to see it, which is nice. And so we're going to say theta is cos inverse of negative 5/8. And I can go ahead and just type that straight in my calculator. Cos inverse negative 5/8. And I get theta is 2.246. And I'm going to go ahead and store that as x. All right, and if we were doing all solutions, that would be 2.246 plus 2 pi k. Okay. Now, the calculator has, we know that we have this amount right here is the decimal, 2.246. So if I want to use my calculator to help me get this answer right here, measuring the angle this way, because that's how we would want to measure it, then it should be the whole circle minus 2.246. So it should be 2 pi minus 2.246. And so again, we're going to be typing in 2 pi minus x. So 4.037. All right. So for this one, we're going to say for cos theta, to get our second answer, we're going to do 2 pi minus x. Okay? So for cos theta, and I guess really I should say, let's go ahead and erase this. I'm just going to say for cos, because we're not really solving the theta. I guess it doesn't really matter. For cos, the second answer is 2 pi minus x, and remember x is the first thing that you found in your calculator. Okay, sorry, I know this is taking a long time, it's kind of boring, I just want you guys to know where all these little shortcuts come from. So last, we're going to go ahead and do a tan example. So I'm going to say tan theta equals 3. And if we think about all students talk constantly, we know we're going to draw a picture in the first quadrant because it's positive in the first. And then tan is also positive in the third quadrant, so we're going to draw a picture there as well. Okay, so if I were to write this as a fraction, it would be 3 over 1. So we have opposite over adjacent, opposite, adjacent. All right, so again, to solve this, we're going to do tan inverse. So theta equals tan inverse of 3. And first quadrant, it's just going to give us the answer that we want. And so I'm going to go ahead and do tan inverse of 3. And I get 1.249. And I'll go ahead and store that as x. All right, and then this angle right here is going to match. That's the 1.249. So if we think about how we want to measure that angle, we would want to measure it like this. And so we would want to do pi plus 1.249. Pi plus 1.249. And so I'm going to say pi plus 1.249. Nope, pi plus x, sorry. Okay. So 4.391. Okay, now what you'll notice is when we do all answers, our answers are going to repeat every pi because this side right here is a straight line, and that's pi. So to get from this answer to this one, I added pi, and then to get back to this one, I'd add pi, and then add pi, and add pi, and add pi, and add pi, and add pi. So we don't need to say this one plus 2 pi and this one plus 2 pi. For these, we can just say 1.249 plus pi k. And that's because tangent answers repeat every pi. Okay. All right, here's the very last example. Tan theta equals -2. And so our answers for this one are going to be in quadrant 4. We know that when tan is negative, quadrant 4, and then also quadrant 2. So opposite over adjacent would be 2, 1, 2, 1. So here, well, this one would have a negative because it goes down 2. This one would have a negative with the 1 because it goes left 1. So that's kind of interesting that the negative sides are labeled a little differently. Okay, so we know that when we do a tan inverse problem and the answer's in the fourth quadrant that we have to do the negative version of the angle. And so I'll go ahead and type that in my calculator. I have theta equals tan inverse of -2. And that's -1.107. I'm going to store that as x. Okay, so if I wanted to get the positive version of this answer specifically, I could add 2 pi. And so the positive version of this answer would be 5.176. And then if I want to think about how I could get that other answer, so this is -1.107. And we know that we would measure it this way. And this isn't really a negative. This is just the decimal 1.107. So if I want to get this, then I would want all of pi, and I would want the negative, right? Like I want this decimal to be taken away from pi. So if I say pi plus -1.107, then that would give me the rest. Pi would be all of this. -1.107 would take away this little part, and then I'd just be left with what I want. So again, I'm going to say pi plus x. So 2.034. So those are my two answers that are on the unit circle. If I wanted to know all solutions, I can just take that first answer I had and say it's -1.107 plus pi k. And you can actually see it. Let me show you if I do x. So there was my original answer. If I do plus pi, I get 2.034. If I do plus pi again, I get 5.176. So you can see that that answer, just when we add pi, we start to get our other answers. And then if I wanted to know coterminal angles, this one would be coterminal to this, plus another pi, that would be coterminal to this, because it's 2 pi away from that. So if we wanted to start getting more answers, we could just keep adding pi, and we'd get the answers.